Right, this is an example of a mixture problem. So as soon as you know that you're going to dump a couple things together here, we're going to make a 3x3 grid. Again, this is your first item, and this is your second item that you're mixing together. It could be coffee, it could be candy, it could be chemicals or mixtures of some type. And so this is going to be our new creation here. This is the amount of just general liquid that you have, or poundage of candy, whatever. This is the value, so it's either a percent or a cost per pound. So here it's the percent, that's alcohol. And then over here is going to be the amount of just the alcohol, which is kind of what I'm focused on here. All right. So we typically don't cross over this brick wall. Every once in a while you know the total amount of the alcohol in the item, but usually not. I start with my percent, so I know this one's 50%. I know this one is 80%, and so this one's somewhere in the middle. And again, one of these should be high and low so that when you mix them together, there's some value in the middle. You can't mix a high and a high and get some value that's less alcohol content. That doesn't work. So one's going to be high and low, and you mix them together, and then you end up with this guy. All right, over here, I know that I need to make 100 total of the new mixture. And so there's only 2 boxes left, which works out great because I need 2 variables there. Now I multiply across to figure out the quantity of alcohol. So this is 0.5x, this is 0.8y, and I'm just leaving the zeros there off because it doesn't matter. And then 100 times this is actually 68. So I end up with 68 liters. That's pure alcohol. So that must mean there's, what, 32 of water mixed into that 100. This equation is your total equation. That's my total amount of liquid. And this is my total amount of alcohol, so it's kind of like the value of it. Like I'm focusing on the alcohol content of this chemical. So I get 60. All right. If you love substitution, you could bring that over and sub in if you want to, or bring that over and sub in. But I like elimination, so I'm just going to take this and I'm going to multiply by a negative 0.5. So this one times a negative 0.5, this one times a negative 0.5, and that one times a negative 0.5. And alright, so then when I do that, I get what? A negative 0.5x, negative 0.5y, and a negative 50. Okay, so that comes down there. Alright, so let's see, these cancel exactly. I get 0.3y equals, what is that, 18? Divide by 0.3. Y equals, and I end up with what, 60? Okay, now I need to look at what that is. That's solution B, which is the 80% solution, and that's in liters. Okay, so I know I need 60 liters of solution B, which is the 80% kind. Again, you need to go back and figure out the rest. So again, the easiest thing to do is to go back in your chart. If this is 60, then this must be 40, so they add up to 100. Or you could go back to this equation if you really feel like it. But if this is 60, 100 is my total, subtract, that ends up being 40. Alright, so there's my answer. I need 60 liters of solution B. That's 80% alcohol. Sorry if I said acid earlier. And 40 liters of solution A, which is 50% alcohol.